Welcome back students to the class of microscopy. In this lecture we will be learning about the stereo microscope. Stereo microscope or stereoscopic microscope or dissecting microscope is an optical microscope variant design for low magnification and observation of sample, typically using light that is reflected from the surface and of the object rather than the transmitted light. There are various parts of the microscope. These are the basic parts of microscope, that is viewing or head or body. Then next part is focus block. Then third one is luminous stand. Parts of microscope. So as I said you all, viewing or head body. Viewing head body that houses the optical components in the upper part of the microscope. As you can see in the image, you can see there is an ocular which is fixed with diopter which you can adjust, and the stereo microscope is having again another part. The part which I am discussing is focus block. Here you can see the focus knob. One is coarse and fine adjustment, that is for focusing of the microscope. Next would be the stand, the luminous stand. Stereo microscope has again another one part, that is luminous stand that supports the microscope and houses any integrated illumination. If there is any integrated illumination, means the transmitted or oblique light or reflected light can be there. So here are the different parts of the dissecting microscope with images where you can see things. So the dissecting microscope or the stereo microscope is having different parts. Here you can see the ocular or lens, or you can say eyepiece, interpupillary adjustment diopter is there. Diopter is for adjustment. Here you can see one is adjusting it. There is lighting cord. Then there is zoom knob. You can zoom in into it. Stereo head is there. Objective lens is there. Then there is a top light from where the light is falling, and there is top light switch again which is controlling the top light. There is an arm, there is a base which is the main part of it, because main part means main mechanical part of it, because it is supporting the microscope. There are stage clips, stage plate, and base is there as I said, and bottom light, that is illumination for transmission. One image I will be sharing with you all that is related to stereo microscope and compound microscope. Let's see what is the difference in these images. So here there is a very clear difference. You can see a three-dimensional image. You can see a stereo image of the eye of the what you can say fly, and you can see very beautiful image from stereo, I must say that. So again, further differences between stereo. So here are the characteristic differences between the stereo and compound microscope. Stereo microscope is having two separate objective, whereas compound microscope is having single objective. And stereo microscope is having two separate optical path, whereas compound microscope is having only single optical path. The imaging by light reflected from the object is in case of stereo microscope, whereas imaging by light transmitted through the object is there. And working with thick solid specimen is possible in case of stereo, but not possible in case of compound, because you require thin sectioned specimen. And stereo microscope typical magnification ranges from 5x to 50x, whereas typical magnification range of compound microscope is 40x to 1000x. There is a three-dimensional image formation using stereo microscope, whereas 2D image in using compound microscope. So here you can see the images of compound and stereo microscope. There is eyepiece. You can see in eyepiece there is a diopter in case of stereo microscope, whereas it is not present in case of your compound microscope. There is an arm in both the cases. There is arm. Objective, you can see there is a nose piece which is fixing the objective in objectives in case of compound microscope, whereas there is only single objective in case of stereo microscope. There is a stage and which is above the light source in case of compound microscope, but the stage in case of stereo microscope is exactly over the light, which is known as the stage plate. Okay, and there is a diaphragm in case of your uh, compound microscope, and both the microscopes are having coarse adjustment and fine adjustment, or focus knob you can say. And there is stage clip for fixing the for fixing the what is it said for the specimen. Now the working principle of the stereo microscopy depends on two light path traveling through the objective and the ocular lens. Each light path provides a different angle, usually 10 and 12 degree of viewing in each of our eye. Our brain processes these two very similar but with slightly different angles images into three-dimensional vision. So here we are watching a stereo microscope. The observer has placed the sample. This is adjustment of interpupillary distance. The person is now observing a motherboard under the stereo microscope, which is a macro substance, macro specimen. This is interpupillary. Now there are diopter and zoom parfocality, camera and microscope parfocality. We will be discussing about things here. This is interpupillary distance adjustment. The specimen is now placed here, and the magnification and clarity is being made. See, this is the view you get in stereo microscope, and as we have already discussed, it gives you a three-dimensional image once you are adjusting the eyepiece with the help of diopter. Magnification is adjusted with the help of diopter. So first you need to set it into 0. The diopter has to be set into 0. You can see 1.25x magnification is there. You'll set both the eyepiece to 0. This is adjustment. Again it is being adjusted. You all know what is coarse adjustment, fine adjustment. This is related to parfocality. You can see different types of grain under it. So the person is now adjusting the diopter and is able to see the grain. The basic thing is to adjust it into to 0, then you will increase the magnification. Now camera parfocality. Camera parfocality means adjusting the differences. See, from the image you get different. This is the C mount camera which you have already seen in the comparison microscope and compound microscope. This is how you use the focus. Let's see the difference between the images which is formed. The one which you are observing and the one which you are able to see in the image. This is your observation, and this image you are getting. As you can see, the image is blurry, so you need to go for focusing of the image. So here in the focus, using the appropriate size of screw, you are adjusting the focus. Now you can see there is a better clarity, and now it has to be locked. So what you are able to do, you are adjusting the interpupillary adjustment, diopter zoom focality, and then the C mount. Transmitted illumination. Since most specimens examined on the stereo microscope are opaque in nature, a top light, that is a transmitted illumination, is used to shed light on it, on the specimen. Some stereo microscope also include bottom light. That means from the bottom here you can see in this image the pointer is being shown. This is a stereo microscope. This is the optical diagram of the stereo microscope. From this portion, as you can see, this portion is being shown here in this image, that is the left hand side image. You can see the laser light, the pointer, and the explanation is given here. Here are the images, the part of it, and we will be dealing with it further in the next slide. So the modern stereoscopic microscope, this is the optical diagram or design of the modern stereo microscope. This A portion, this one, as you can see, this is the objective lens, and it is present over here, this brace of the stereo microscope. This B portion, which you can see the laser light is falling on which, is the Galilean telescope, or it is known as the rotating objectives. Okay, and then passing to C, that is this knob. This knob is actually the knob over here. Okay, this knob is for controlling the zoom controlling, so it can be twisted or turned to enhance zooming or so on. Okay, and then we go to D. This lens is present inside here. Okay, so this lens is edges next to the B portion. Okay, is over this. That is, this lens is internal objective lens. Internal objective lens is somewhere here. Okay, and when we go beyond it, you can see there is a prism like structure which is bodied in the head, in below the eyepieces in the head. It is bodying prism. Okay, and F, which you can see here, somewhere here it would be, it is actually the relay lens. Okay, and then this H, this G, where this is the portion, this is the place, this is reticle, and this H means this whole portion, or this whole portion is the eyepiece or ocular lens. So let's now discuss about the different types of stereo microscope. Stereo microscopes are of different types, as in the stereo fixed microscope. The term fixed means it is fixed to one of the microscope, refers to one of the microscopes used in stereo microscope. Okay, the fixed magnification uses two objective lenses. You are having one objective here and somewhere here, another objective would be there, which refer to an optical and to the optical element gathering and focusing the light rays on the image. The magnification has a fixed degree and is limited to the capability of the lens. Changing to a stronger eyepiece, if I am changing this eyepiece to a stronger eyepiece, okay, it would increase or zoom in the images. This can be useful as you cannot change to higher or lower magnification while viewing a specimen, therefore it is kept in stable focus. So this is one type, that is stereo fixed microscope. Next is your stereo turret microscope. So this is the stereo turret microscope. Here I'm having this turret. Okay. So here, what is the difference? These type of microscope come in variety of mounting. There is mounting, one of which is turret style. Okay, objective turret is another term, that is turret is here for this type of mounting and indicates that an additional objective lens can be rotated into viewing position. This easily allows the viewer to change magnification by simply rotating. Here one is rotating the turret mounting. One would be rotating the turret mounting. And stereo turret microscopes are less flexible. Okay, as you can see, it is fixed. And the meaning of this type of microscope, with this, there is less flexible than in case of zoom type of microscope. Okay, turret means a very small tower on the top of large building. So it is a small tower, or you can say it is one small objective which can be adjusted. Okay, so comparatively this is more economical. The next type of microscope or stereo microscope which we will be studying is stereo zoom microscopy. To stereo zoom microscopy means, as the name suggests, stereo zoom means you can zoom a little bit more. Okay, so the stereo zoom microscope behaves as much as that of as the name implies. This microscope can zoom in or zoom out to increase or decrease the desired magnification. The available range can also be altered by changing to stronger eyepiece. If you want to change the eyepiece, you can change it and you can view them. The stereo zoom microscope comes with choice of stands. So there are two types of stands. One is simple stand and another one is boom stand. So a simple stand microscope or simple stand stereo microscope allows room to observation and repair of items such as watches, coins, and even some entomology and even some archaeological samples. Whereas boom stand is for larger application and can be mounted on the floor and have added a boom to act on as counterweight. Okay, so the boom stand would be fixed in one place and the head would be movable, and you can see an object which is fixed in a position. Okay, the next type of stereo microscope is digital display stereo microscope. It is going to display the image as it is. You can see the object below, and you can see the image of it in the camera. So there are dual camera pickups and have been fitted to the stereo microscope, allowing the images to display on the high resolution LCD monitor. So next is the uses of stereo microscope. While it is erect and three-dimensional image can be seen, and inside dissection can be done, detailed work such as microsurgeries and watchmaking can be done. Tool mark examinations can be done. Commercial inspection applications such as soldering, circuit board inspection, repair, engraving, and any macro or comparatively less magnification, wherever less magnification is required, one can go for stereo microscope. And if it is requiring three-dimensional image, then also one will be going for stereo microscope. This is all for stereo microscope.